We're still in module 14.1. Wow, they really gave you a lot in this one, didn't they? And I'm going to now teach you how to find square roots and cube roots of numbers. Before we jump into what is a square root, let's review what a square number is. So let's say I've got the number 4 squared, and this is your base number right here. Remember that? And you also have an exponent. And the exponent tells you how many times to multiply the base number times itself. So in this case, 4 squared would mean 4 times 4, which equals 16. If you have the number 7, 7 squared means that it's 7 times 7, which equals 49. And so these two numbers right here that we just came up with are considered perfect squares. They're square numbers that are perfect, and the reason that they're considered perfect squares is you used integers. Remember, integers are positive or negative numbers that don't have fractions, that don't have decimals, that don't have anything else. They're just like whole numbers and integers, because the integers part, remember, that includes the negative numbers as well. But they do not have decimals, they don't have fractions or anything like that. So we just have number 7, multiply them together and you get 49, and that's it. No decimals, no anything, okay? So they're considered perfect squares. Now, a square root is kind of like working backwards from here. If you were given, this is a symbol for a square root. It looks like this. It kind of looks like a division sign, but don't get confused by it. It has this little hook in the beginning of it, in the front of it, okay? And so this is a sign for a square root. And so this is how it would look to you. So this would be the square root of 49. And essentially what this is asking you is, it's saying, what is the square root of 49? And that's essentially asking you to go back and forth. Because it's a square, it means that you have two numbers that are multiplied by each other. And our answer is 49. That's going to be what we would get if we multiplied the same numbers by each other. And so it has to be the same number. So what number times itself gives you 49. And in this case, we already know that the answer is 7. 7 times 7 equals 49. And so the square root of 49 equals 7. It's essentially saying get to the base number. If I have something squared, what is that base number if it equals 49? That's essentially what a square root is, okay? So, given this problem, let's work on this. The square root of 16 is essentially saying what number times itself equals 16? Well, we know that that equals 4, because 4 times 4 equals 16. So the square root of 16 equals 4. This is just my thinking over here. This is not part of the problem necessarily. This is just my thinking. This is what you would be writing. Essentially, a square root is just a way you can simplify a number by writing it out like this, okay? You will not be given the problem this way, though. You will be given a problem most likely like this. It'll look like this. X squared equals 25. So whenever you do problems like this, you're looking to find out what x equals, right? You want to get the x by itself, and you want to find out what that x equals. So in order to work on this problem, in order to get the x by itself, I have to get rid of this square. So I have to say, what is the square root of this number? What number did I multiply by itself? So I multiplied some number times some number to give me x squared. What number would that, or what would that be that I multiplied together to get it? I would multiply x times x equals x squared. Does that make sense? So I have to take the square root of this in order to get me to my x. But whatever I do to one side, I have to do to the other. And so you're going to take the square root of this side, which give you x, and on this side, you're going to take the square root of 25. So what number times itself equals 25? You're right, 5. In this case, the square root of 25 is 5, and so this would be my final answer. That's how it's going to look. Let me do another one for you. Let's do x squared equals, let's do 36. Okay? That's how you're going to be given the problem. All right? So you're going to have to get the x by itself. In order to get the x isolated by itself, you're going to have to take the square root of it. So I'm going to take the square root of this side. Whatever I do to one side, I have to do to the other side to keep it balanced because they equal each other. So square root of x squared equals x. It's essentially saying what number times itself gives me x squared, which would be x, because x times x equals x squared. That means I've got to simplify this side. What's the square root of 36? What number times itself equals 36? That's 6. And that's my final answer. Okay? Now, there's another thing that you need to know, and that is the cube root. So, Matthew was saying the other day that a cube is essentially length times width times height. That's where they get a cube from. But in the past, you did, let's do 2 cubed, meant you took your base. The exponent tells you how many times to multiply it by itself. So 2 times 2 times 2 would be how you work this, how you expand this, and you would end up with 8. 2 times 2 equals 4, times 2 equals 8. And so 2 cubed equals 8. This, number 8 then, is now called a perfect cube. Okay? And so, breaking this apart, I now show a symbol of this. It looks like a square root, but this puts a 3 on the outside, just like that. And so it's telling me what number times itself 3 times gives you an answer. In this case, let's do 27. What number times itself 3 times gives you 27? Well, I know it's not 2 because that was 8, right? So let's try 3. 3 times 3 times 3. 3 times 3 equals 9. 9 times 3 equals 27. So the cubed root of 27 equals 3. It's just asking you how many times, or what number times itself 3 times gives you that answer. So that's a perfect cube. Let's talk really quick. I should have explained something. Going back here for a second, back up a page for a second. When I was doing square roots, I should have told you that when I did the square root of 36, this actually should be a positive or a negative 6 here. Because if I multiply 6 times 6, it equals 36. Or if I multiply negative 6 times negative 6 equals 36, because a negative times a negative equals a positive, right? So when you do something with square roots, you can do, this is how you represent it. You would say the square root of 36 equals a positive and a negative on top of each other, 6. So it shows that they can be either positive or negative. I hope that, I know I talked about that in class the other day. I know I'm bringing that back up. Talk to a neighbor if that's a little bit confusing to you. But when we're talking about square roots, since they're 2 numbers being multiplied by each other, the answers could be positive or they could be negative. Because 2 negatives equal a positive when you multiply it by each other. But in cube roots, I know I was talking to Sophia and Dominica about this the other day too. It can't be positive or negative. It has to just be a positive number, because if they were negative numbers, negative 3 times negative 3 times negative 3, well, this would equal positive 9 times negative 3, that would equal negative 27. And that is not what we're looking for. We want it to be the square root or cube root of just positive 27. So it can't include negative numbers. So square roots, put this in your notes somewhere, include positive and negative numbers. I hope this sinks in now that I'm doing it as an afterthought. And cube roots are only positive. Put those in your notes somewhere. So that can help you keep that straight. So let me go over 2 more problems with you, okay? Just to make sure we've got that. So if I'm going to do the square root of, let's do 81, I'm going to ask myself what number times what number equals 81? And that answer can be 9. 9 times 9 equals 81. Or negative 9 times negative 9 equals 81. Does that make sense to you now? So the square root of 81 actually equals positive or negative 9. Does that help a little bit? Okay, so I wish I could go back to the beginning of the video and clarify that for you, but I'm not going to go back all the way now. Make sure you make that clarification and learn from it if I forgot to tell you about it before. Maybe it'll sink in a little better that way. And then we have the cube root. Cube root of, wow, I think they go really quick. Cube root of 64. Let's see. 4 times 4 equals 16. And 16 times 4 equals 24. And so that equals 64 right here. And so the cube root of 64 is 4. See how they get big so quick? So here's what I want you to do right now. I want you to take a minute, a couple minutes actually, to make a chart in your notebook. And I want you to make columns, okay? In there, I want you to give me the number. So if I'm starting with 2, I want you to give me the square. And I want you to give me the cube. So the square is 2 times 2, which equals 4. And the cube is 2 times 2 times 2, which equals 8. You don't have to put this work in there. You could just do, 2, 4, and 8 if you like to. Going on to 3. So 3 times 3 equals 9, and 9 times 3 equals 27. Then I'll go on to 4. 4 times 4 equals 16, and 16 times 4 equals 64. You can use a calculator for this part, but the reason I want you to do this, I want you to do it all the way up, probably through 25. The reason why I want you to do this is now, if I was finding the cube root of this number, now you have a chart. The cube root of 64 is 4. The square root of 16 is 4. Don't put these in there right now. Don't put these in there. But just put 5. 5 times 5 is 25. And 25 times 5 is 125. So if you now need to take the cube root of 125, you now know that it's 5. Does that help you? It will for sure in the future. So go up to, take all these numbers down to 25. Make them neat. Keep it in a notebook. Keep it somewhere where you can reference it so you don't have to calculate it in your head every time. That should take you some time. And come back for my last video of the night.